Hello, today we're going to be talking about types of solutions, and more specifically, there's three types of solution. There is infinitely many solutions, one solution, and no solutions. At the end of this video, I'm going to show you like a visual representation of each of those um, scenarios and how to look for them for future problems that you might encounter. But it's going to be in a different way from this worksheet that I'm doing. Okay, let's just run it down. Okay, infinitely many solutions. It's basically once you do your math and figure out that you get like a number is equal to another number, and it makes sense. In this case, like 8 is equal to 8, which is true, then that means that no matter what variable that you put for or whatever value that you put for the variable, in this case x, it'll be true all the time. As you could tell, look, this is just a different form. These two things are exactly the same because look, if you distribute, you get this, which is exactly the same equation. So of course they're going to give you the exact same answer. And then that is for the infinitely many solutions. And then we have this. Whenever we do some algebra and we figure out that we get the variable is equal to one specific value, then that means that we have one solution, of course, because it's only equal to that one value, and only that one value will make this equation true. Um, and then for no solution is when you get it's the opposite for infinitely many solutions, where you have two numbers and you set them equal to each other after once you do some algebra, and it basically means like nothing will ever work. No matter what value that you put for the variable, in this case x, this equation will never be true. It will never work out no matter what you put. That's basically what it means for no solutions. Okay, now I got the explanation done. Let's do some problems. Let me turn the light on. Hopefully to make it brighter. Okay, problem one. We are determining whether the solution has, or the equation has one solution, infinitely many solutions, or no solutions. That's what we're trying to do. The first one. Okay, this is our equation. Okay, first things first I like to do is, draw the line, the imaginary barrier, and we have to pick a side. We gotta pick a side for the variable. In this case, it's x. So we gotta say which side is the x side. I'm just gonna say this side is the x side because it's gonna make a positive x. That was like the positive variable side, um, if possible, because you may not know. And the other side is the number side, so everything else is on the other side. First things first, since there's a variable on this side, we gotta put it on the other side. The way we do that, we gotta cancel this out. And since this is a positive x, whenever we move it to the other side, we have to do the opposite of whatever this thing is. So since it's a positive x, so we gotta do a negative x. We minus x on both sides because whatever we do one side to the equation, we have to do to the other side. These cancels out because we got a positive x and then a minus x. Now we got 3x minus x, which is just 2x. Minus 2 on that side. We haven't done anything. That 6 is still there. Now we have let's look on the left side, and we notice that there's a number on that side, and we said that this side is a number side, so we got to move it. Once again, we got to cancel that number out. Since it's a negative 2, we got to add 2 in order to cancel out. Whatever we do to one side, we have to do to the other side. all we're left with on this side is just 2x. And then we got 6 plus 2, which is 8. We got 2x equals 8. Now we have to get x by itself. Divide by 2. Divide by 2. The reason why we're dividing by 2 is because we want to cancel these 2 out in front of the 2 in front of the x, because it's another way of saying 2x is 2 times x. And the opposite of multiplication is division. And you want to make that number go away, or make it equal to 1 actually, more specifically. So this will just become just a 1, so it's going to be just 1x, or just x. You can just write down just x. And we divide the other side by 2, because whatever we do to one side, we gotta do to the other side. Now we have 8 divided by 2, which is 4. And we got x equals 4. So if we were to look at our types of solutions, notice how this one says basically a is a number, and it's equal to the same number, a. And over here, it's x equals a number, which is just a, and then over here is a, which is a number, and then b is a different number, and it's equal to each other. Which, if we were to look at which one does it look like, it's actually this one, which means it's one solution. So this is just one solution, which is x equals 4. Now let's do number 2. We have 5x, 10. First things first, on this, since we got the parentheses, we gotta distribute. We got 5 times x equals 5x. Oh, I forgot to draw the imaginary line, the wall. 5 times negative 2 is negative 10. We didn't do anything on this side. Notice how they're exactly the same thing, but we still want to cancel, or we still have the idea of getting x on one side. And the way that we do that, just pick any side. Let's say that this is the x side. So this means that this is a number side. Not necessarily, you don't have to do this because of what's going to happen. We have minus 5x on this side, minus 5x on this side. This cancels out too. This cancels out too. So we got negative 10 equals negative 10. So we can stop here, or we could just continue this numbers. We could say we can move the this negative 10 on the other side, the way that we do it, positive 10, positive 10 on this side. So it's going to be 0 equals 0, which is true. You could have stopped at negative 10 is equal to negative 10, because it's the same number is equal to each other, which is this. So this means that this has infinitely many solutions. And notice how we have this equation right here. This thing is equal to the same thing. Of course it is. It's the exact same equation. If you look over here, when we went on the second step, after we distributed, we got the 5x minus 10 is equal to 5x minus 10. So of course, yeah, they're exactly the same. So it's the same equation. So in this case, we have infinitely many solutions. Infinitely many solutions for this. Now we have this. Okay, we got 6. Okay, we can't do anything on this side. Let's just draw the line so we just keep it consistent. Imaginary line. Let's see. First, let's distribute. Now, 6 times x is 6x. 6 times positive 2 is positive 12. We didn't do anything to the other side. Now we have this. Let's cancel. Notice how there's a 6x and 6x on this side. We could just cancel them out by subtracting 6x on both sides. You see how this cancels out? And then this cancels out. So we're left with a negative 1 is equal to a positive 12. Does that make sense? Does negative 1 equal to 12? No, it's not. So if you're to look at the types of solutions, we got a number is equal to another number, but it's not the same number. So we have no solutions. So no matter what value that you put for x, it will never, this equation will never be true. So there are no solutions. Now number 4, we have 8x plus 2. Okay. Now let's see if we can zoom in a little bit more closer. Hopefully that worked. Alright, let's see. It's not as clear, but let's see. Okay. I think that's the best I could do. Yeah, I wish I could be a little bit more focused. It's somehow not being on focus. Let me see if I can maybe make it better. I'm not sure if that made it better, but it looks better, at least from the video. Okay. So we have this. Back to the same thing. Let's just draw the line. Little imaginary wall that we have. Okay, now we have the parentheses, so we got to distribute. Okay, so we got 8 times x equals 8x. 8 times 2 is 16. We have 8 plus 16 over here. Notice how they're the same. So look, we both have an 8x on both sides, so we can just cancel them out. We could have just stopped here and just assumed, it's pretty obvious that these are the same equations just by looking at it. But I'm going to do it the way that the worksheet is doing it, so it can be consistent. We cancel 8x on both sides. These cancel. So we got 16 is equal to 16. And if we were to look at the types of solutions, we got a number equals the same number. So this means that we have infinitely, I wrote it on the many solutions. Sorry, I made it on the line. I was like, oh, my L was on it. So kind of, oh well. Yeah, so it is infinitely many solutions. Now, let's see. Number 5. Writing down the problem. Okay. First thing I like to do is, draw the imaginary wall. Okay, now we have a parentheses, so we got to distribute first. The order of pandas. Okay, we got 2 times x, which is just 2x. 2 times negative 3 is negative 6. We have 2x on this side. We got as well. We got plus 4 on that side. We have 2x's on both sides, so we can cancel them out by subtracting 2x on both sides. It's exactly the same. Boom, boom. So we get negative 6 is equal to 4. Now, negative 6 does not equal 4. So we got one number is equal to another number. That is not true. So if we were to look at the types of solutions, we notice that it is this form. It is a number not equal to a different number, which means that this equation, no matter what value that you put for the variable x, there are no solutions. Yeah, x plus 4 equals 3x. No, not the quantity of x. Okay, there. Okay. Draw the imaginary line. I like to do that. You don't have to do it, but I like doing it. Especially to make it more clear on which side is which. Okay, so we have 3x, or 3, okay, we gotta distribute. Sorry, I got ahead of myself. 3 times x is 3x. 3 times negative 2 is negative 6. We got x plus 4 over here. We didn't change anything. Now we just, since they're not the same, well, we have to pick a side. Let's say that this side is the x side. So this means that this side has to be the number side. So we got to get all the x's on this side, all the numbers on this side. Since there's an x over here, we got to move it to the other side. How do we get rid of this positive x? We have to subtract x. So we have to subtract an x because we want it to move on away. There's no x's on this side. And whatever we do to one side, we have to do to the other side. So we got 4 equals 3x minus x, which is 2x. And then we got minus 6. Now we have a number on the x side, so we got to move it to the other side. So how do we get rid of this negative 6? We have to add 6 on both sides. Boom, it cancels out. We got 4 plus 6 is equal to 10. Now we got 2x equals 10. Well, there's a number, we just want x by itself, but there's a 2 in front. Another way of saying 2x is 2 times x. And how do we get rid of the 2? To just make it a 1, we have to divide by the same number. And this number is 2. Because 2 divided by 2 is just 1. So that cancels out, but whatever we do to one side, we have to do to the other side. And then we got 10 divided by 2, which is 5. And we're left with x on this side. So x is equal to 5. And if we were to look at the types of solutions that I have right here, we have x is equal to a number, which is this. So this means that we have one solution. Or not solutions, solution. There. Okay, let's see. I think that's it, yeah. I think that's pretty clear. I feel like I should not do what I wanted to do at the end, because I wanted you guys to see like the formulas, because these are all lines that we're doing right now. And I kind of wanted to describe the what do you the I wanted to write it in y-intercept form. So I wanted to do it in a different way of explaining it and what it means visually, but I don't think that it'll be a good idea to uh, show you a different form if it's not related to this worksheet. But I will just show you like essentially what's going on. So for uh, infinitely many solutions, what's going on is we have a line and then we're setting it equal to the exact same line. So there's an overlap on with itself. Say that they give you this part of the line, like they give you like a certain equation, and it's like, oh, it's here, but they give you the, well, a line goes infinitely in both directions. So, and they give you a different one where it looks a little bit different, but it's still the same line. It's just overlap. It's the exact same line. And that's how you get the infinitely many solution. Now for the one solution over here, we basically got two lines, but they are um, they have a different slope and they have a different or they don't have to, but they can have a different y-intercept. Um, but they have a different slope essentially, and they intersect at one point. So this is the only time whenever that they uh, where both the equations are equal to each other and they present a solution where the equation is true. In this case, this equation is equal to this equation only at this point x is equal to 5. So that's what it means for the visually what's going on. And then we got no solutions. We got like one line and then we got another line that is parallel to this line. And what it means by parallel, it means that these lines will never intersect. There's like a little symbol, like these little arrows to show that these are parallel. But basically what's happening is this has the same slope as this one, or and vice versa. These are exactly the same slope, but they have different intersects. So intercepts. Uh, so they do not intersect. Yeah, they have different y-intercepts, and they do not intersect because they have the same exact slope. They're parallel. So this will be the no solution. Uh, Side or no solution, not just no solution. No solutions because no matter what you put, it's no solution. Uh, but yeah, that's a visual. I wanted to show you like what it means by the actual equations and what it looks like, but it's a little bit off. But this is just a little visual on how you can look at it. What what it means to be infinitely many solutions, no solutions, and then one solution. Like a little visual on what you can see. I think I'll stop it there and I'll go to the next one.